Hello everyone. Today we are going to deal with the law of octaves in periodic classification of elements. The law of octaves was proposed by John Newlands in 1866. Let me ask you, do you like music? What about keyboard? Are you familiar with the musical notes sa, re, ga, ma, pa, da, ni, sa, and English form do, re, mi, fa, so, la, ti, do? That was fun, right? Now, let us move on to the observation. The first note sa and the eighth note sa, they are the same. This is an octave, right? Yes, I want you to remember this concept when moving on to our subject. Let's go back to John Newland and the octaves. He arranged the known elements in order of their increasing atomic masses, inspired from Dobrenier. Now, what he did was he started with the element having the lowest atomic mass, that was hydrogen during that time, and ended at thorium, which was the 56th element. So there were 56 elements during that time. Now, moving on, he found that every eighth element had the properties similar to that of the first, just like the musical note. So he named them the law of octaves, which is also known as Newland's law of octaves. Now, this is a model prepared by him. Let's see. If his observation is right, the lithium and the sodium will be having similar properties. Why? Lithium is the first element, sodium is the eighth element. Just like that, beryllium and magnesium. Beryllium is the first element, magnesium is the eighth element. So beryllium and magnesium should be having similar properties, right? Yes, just like that, boron, aluminum, calcium, silicon, nitrogen, phosphorus, oxygen, sulfur. Let's see. The properties of lithium and sodium were found to be similar. Okay, so his observation was right. Moving on. Sodium is the eighth element, we know that. After lithium. Similarly, beryllium and magnesium resemble each other, like we said. Now, it was also found that the law of octaves was applicable only up to calcium, as after calcium every eighth element did not possess properties similar to that of the first, and that's a disadvantage. The law of octaves was followed only up to calcium. What about the chromium, titanium, manganese, iron? They didn't. Now, what about the second one? It was assumed by Newland that only 56 elements existed in nature. That was a wrong statement, and no more elements would be discovered in the nature. But later, several new elements were discovered whose properties did not fit into the law of octaves. That's second disadvantage. Moving on, and in order to fit elements into his table, the Newland adjusted two elements in the same slot, but also put some unlike elements under the same node. Let's see. On the first group, cobalt and nickel, just like they said, adjusted two elements in the same slot, cobalt and nickel. He placed them along with hydrogen, fluorine, chlorine, and bromine. But you know something? Cobalt and nickel had a different property than hydrogen, fluorine, chlorine, and bromine. And you know something? Iron, the last one in the last group, iron is similar to cobalt and nickel. But see where they are. They are in different groups, right? That is also a disadvantage. Let's see. Note that cobalt and nickel, just like we said, are in the same slot in the first group, and they are placed in the same column as fluorine, chlorine, bromine, which have very different properties than these elements, just like we said. Now moving on, iron. We told about iron, right? Which resemble cobalt and nickel in properties, has been placed far away in the eighth group. Thus, the Newland's law of octave worked well with lighter elements only up to calcium, right? Yes, that's it. So, the Newland's law of octaves was also a kind of failure. That's it. Thank you.